For 76 years, we have been lied. We grew up learning that Pluto was the lonely little planet at the end of the line. We saw it in our elementary school textbooks. We hung it on our classroom wall next to the periodic table. Every toy store in America sold that glowing plastic solar system mobile, and Pluto was that tiny little speck at the very end of the arm. Then, in 2006, they ripped the title away. The International Astronomical Union voted, and just like that, Pluto was demoted. Most of America stopped paying attention. We figured the story was over. Frozen rock at the edge of the sun's reach, stripped of its status, forgotten in the dark. That is the version of Pluto still bouncing around in your head right now. And I am here to tell you that almost none of it is true. Because while we were busy arguing about what to call it over here on Earth, Pluto was busy becoming one of the most violently complex, chemically chaotic, and scientifically embarrassing objects we have ever encountered. And when NASA's New Horizons probe finally got close enough to see it clearly in 2015, what it found didn't just surprise the scientists at Johns Hopkins and the Jet Propulsion Lab, it broke their models. To get why this matters to us, we have to understand where Pluto lives. It orbits our sun at an average distance of about 5.9 billion kilometers. That's roughly 39 times farther from the sun than we are. At that distance, sunlight is about 900 times dimmer than a summer afternoon in Texas. Noon on Pluto looks like deep twilight in a cave. The surface temperature sits around minus 230 degrees Celsius. That is cold enough to freeze nitrogen solid. Not water, nitrogen. The air itself turns into rock. For decades, every physics model we had said the same thing. At that temperature, at that distance, with a body that small, roughly 1,400 miles wide, smaller than Earth's moon, Pluto should be dead, geologically inert, a frozen ball of dirty ice with the personality of a parking lot. That was the scientific consensus going into July 14th, 2015. Pluto was a relic, space junk. New Horizons had been flying for 9.5 years. It was a bullet, moving at nearly 31,000 miles per hour. It couldn't slow down, it couldn't orbit. It had one shot, a few hours to grab everything it could. It was the most stressful flyby in a generation. When the data started streaming back to Earth, the old version of Pluto evaporated in about 10 minutes. The first image that stopped the team cold was a region called Sputnik Planitia. Look at this. It's an enormous plain of nitrogen ice sitting inside a massive impact basin, roughly 750 miles across. From a distance, the science team thought their cameras had glitched. It looked smooth, too smooth. In space, smooth means new. In our solar system, small, cold bodies look like a golf ball, covered in impact scars billions of years old. The moon is covered in pockmarks. Mars is red with dust and craters. But Sputnik Planitia had almost no craters. The surface appeared to be less than 10 million years old. On geological timescales, that is literally yesterday. Tuesday, maybe. When the high-resolution images came in, the smoothness turned out to be a lie. The plane isn't flat. It's divided into irregular polygons, each one roughly 10 to 25 miles wide, separated by shallow troughs. Those cells are convection patterns. The nitrogen ice is slowly churning. Warmer ice from below rises to the center, spreads out, cools, and sinks back down along the edges. Sputnik Planitia is turning itself over like a lava lamp running in slow motion, completing one cycle roughly every 500,000 years. On a world that was supposed to be frozen solid, the ice is moving. Here is the immediate problem for American science. Where is the heat coming from? Pluto has no giant planet squeezing it like Jupiter squeezes its moon Io. The sun is just a bright star in its sky. The only explanation is internal heat, radioactive decay in Pluto's rocky core. But Pluto is tiny. A body this small should have lost its heat billions of years ago. The math didn't work, and yet
the convection is right there in the raw data. Undeniable. The geology didn't stop there. New Horizons found mountain ranges made of water ice, some of them rising nearly 11,000 feet above the surrounding terrain. Think of the Rockies, but made of material harder than granite because of the cold. These mountains weren't eroded stubs. They have sharp edges, clean faces. They formed recently, maybe within the last 100 million years. Something is pushing up mountains on a world that should have gone quiet 4 billion years ago. And then there are the glaciers. Not water glaciers, nitrogen glaciers. Pluto has flowing rivers of frozen nitrogen that creep down from the highlands and pool into Sputnik Planitia. They move imperceptibly slowly, but they carve channels. They leave flow marks. On a world where it is negative 364 degrees Fahrenheit, there are active glacial systems reshaping the landscape. I want you to sit with that. We have trouble keeping Interstate 90 intact through one winter in Ohio. Pluto is running a geological resurfacing program at temperatures that would turn our lungs into a solid block.
But the game changer, the thing that forced NASA to go back to the drawing board, is a feature called Right Mons. It sits in the southern hemisphere, roughly 90 miles across and about 2.5 miles tall, with a massive dent in the summit that looks exactly like the caldera of a volcano on Earth. The New Horizons team didn't want to say it at first. Claiming a volcano on a tiny frozen rock is dangerous for a career, but the evidence kept coming. The terrain around Right Mons has no craters. It was resurfaced recently. The texture is lumpy, hummocky, exactly what we'd expect from material extruded from below that froze in place. This isn't a Mount St. Helens eruption. If you could stand next to Right Mons, you wouldn't see red lava. You'd be standing in near total darkness, on ground that crunches like styrofoam, looking up at a mountain that vomited a slurry of water, nitrogen, and methane into a sky so cold the lava froze solid before it could flow. A cryovolcano on a dwarf planet, doing something the math says is impossible. As New Horizons flew away, it turned back and took a picture of the sunset, and that picture nearly broke the internet at Mission Control. Pluto has an atmosphere. It shouldn't. Its gravity is too weak, but it does. A thin envelope of nitrogen, methane, and carbon monoxide that stretches 1,100 miles above the surface. When the sun set behind Pluto, the atmosphere lit up in layer after layer of blue haze. The blue color comes from tholins, complex organic molecules. Essentially, ultraviolet light from the sun is cooking the methane in Pluto's sky, breaking it apart and reassembling it into complicated chemical compounds. These tholins rain down to the surface, coating everything in that distinctive reddish-brown color. That rusty color we see in every photo, it's not dirt. It's organic chemistry raining out of a sky that is 100,000 times thinner than the air we are breathing right now. Pluto's orbit is highly elliptical. It takes 248 years to go around the sun. When it gets closer to the sun, the surface ice turns directly into gas, sublimation, and the atmosphere thickens. When it moves farther away, the atmosphere freezes and collapses back onto the ground. Pluto is breathing. It inhales and exhales its own sky over 2.5 centuries. And get this. In 2018, researchers dropped a bombshell in the journal Science. They found dunes on Pluto, sand dunes. But on Pluto, the sand grains are made of methane ice. The wind isn't pushing them, the wind is too weak. Instead, as the nitrogen ice turns to gas, it kicks methane particles into the air, and the faint breezes carry them downwind. Dunes built by an atmosphere that barely exists. We have never seen anything like this anywhere else. Now we get to the part that keeps astrobiologists up at night, the part that might change how we look at the night sky. Analysis of Pluto's gravitational field suggests that deep beneath the surface, under the nitrogen ice, under the water ice bedrock, there might be a liquid ocean. Think about that. A body of liquid water 3.7 billion miles from the sun in permanent, absolute darkness.
how is it not frozen? Ammonia. The water is likely mixed with ammonia, which acts as a natural antifreeze. A study in 2019 suggested that a layer of gas hydrates acts like a winter coat, trapping the heat from Pluto's core and keeping the water warm for billions of years. If that model is correct, Pluto has maintained a hidden ocean for the entire history of the solar system, longer than complex life has existed on Earth. Here in the US, when we search for life, we usually look for Earth-like conditions: sunlight, warmth, a nice atmosphere. But down in the deepest trenches of our own Pacific Ocean, we have found entire ecosystems thriving in total darkness. Microbes feeding on chemicals from hydrothermal vents, bacteria living inside Antarctic ice sheets. If Pluto's ocean touches a rocky floor, and if that rock is even slightly warm from radioactive decay, we have the exact same ingredients: liquid water, minerals, and an energy gradient. Let me be extremely clear. I am not saying there are fish on Pluto. But the fact that we cannot rule out habitable conditions on a world we forgot about after a naming dispute, that tells us everything about human arrogance. A decade ago, a scientist suggesting Pluto might have a liquid ocean would have been laughed out of the room. Now it's a line item on NASA's budget wish list. We can't ignore Charon. Pluto's moon is actually half its size. They don't orbit like Earth and the moon do. They orbit a point in empty space between them. They are binary partners, locked face to face, spinning like two skaters holding hands.
Charon has a massive canyon system stretching across its equator, chasms 5 times deeper than the Grand Canyon, and its north pole is stained a deep, bloody red. Scientists call it Mordor macula. The leading theory is that methane gas is leaking off Pluto, drifting 12,000 miles through space, getting trapped by Charon's gravity, and being cooked by solar radiation into red organic gunk. Pluto is painting its neighbor with its own atmosphere. So here is the pattern. Every time we send a US spacecraft to something small, cold, and far away, something we assumed was boring, it turns out to be extraordinary. Enceladus, Titan, Triton, and now Pluto. What scares planetary scientists isn't what we found, it's what we haven't found yet. Pluto lives in the Kuiper Belt. There are thousands of other icy bodies out past Neptune. Eris, Makemake, Haumea, Sedna, which takes 11,000 years to orbit the sun once. We have assumed they are dead rocks for our entire lives, but we have almost no close-up data on them. We have been assuming they are boring because we never bothered to look. And if Pluto, the king of the Kuiper Belt, is this alive, this violent, this chemically complex, what the hell is going on with the rest of them? We spent 76 years calling Pluto a planet. We spent 9 years arguing about whether it deserved the title, and we spent exactly 0 years understanding what it actually was. The argument over the name was always a distraction, a bar fight for the internet age. Pluto doesn't care what we call it. It is out there right now, 3.7 billion miles away, doing things we can't explain, on a timescale we can barely comprehend, in a darkness we will never fully penetrate. The most unsettling part of this story isn't the ice volcanoes or the breathing atmosphere or the hidden ocean. It's the implication. If we were this wrong about Pluto, something we've known about since 1930, what else are we dead wrong about? How many other dormant, dead, boring rocks out there are actually hiding liquid water and organic chemistry? We have barely scratched the edge of our own solar system, and the edge, it turns out, is more alive than we ever imagined. Thanks for flying to the edge with me. I'll see you in the next one.